Good morning, everybody. Happy Tuesday. Today in science class, we are going to move on from matter to energy. So we're going to be starting a new chapter called energy, obviously. So if you can see from this title page, we have this, I think this is from Dragon Ball Z, right? This giant ball of energy. Energy, we use it every single day. We're actually seeing it right now. If you can see the sun coming out my window, I can also turn off the light like that. I am using energy this way. When you eat, when you chew, that's also using energy. Batteries, your phone, your chargers, all this good stuff, lights, that's all energy. So let's go ahead and dive in. Now, I already gave you some examples on how I use energy. Now, take a time to brainstorm on ways that you use energy this morning. As you can see, the refrigerator uses energy. We have the lights switch here. Eating a giant piece of bacon takes a lot of energy. Even going to school takes energy, not just because you need to be energized to go to school, but because our school buses and cars and subways, all that useful stuff uses energy every single day. So our science textbook actually defines energy as the ability to do work. So here we have three types of energy. Electrical, so those are our lights, right? Sound, so if I'm playing music, that's also energy. And of course, we have our light energy that we are very thankful for. God created light on the first day. That's also energy. We also got mechanical energy. So those are our cars, our buses. And chemical energy, when we eat and our body digests that food, that is using chemical energy. Now, energy will not be very useful if it couldn't change forms. For example, batteries, which starts with a chemical energy, and then when you put it inside a flashlight and you turn it on, ta-da, it turns into electrical energy. So it's important that energy can change from one form to another form. Now we're going to look at two different types here, potential energy and kinetic energy. Just think of a roller coaster. Potential energy is when you are on the top of that roller coaster, that D-Express in Everland, and you're about to go down, but it's not moving yet. It's the position. So it starts with P, right? This also starts with P, potential, position. And then when it goes all the way down, that is kinetic energy. That's the actual motion. So we're actually going to go on a virtual roller coaster ride. So right now, it didn't start, it's not going down yet. It's going to actually stop. I'm going to stop it with my mouse. So it's moving, it's moving, it's moving, it's moving, kinetic, 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 kinetic energy, still kinetic energy. Once it stops right over here, and you feel like your heart's about to pound, and maybe there's a camera that's trying to take your picture when you're going to scream, that pause would be the potential energy because it's in this position. And then, woo, that is kinetic motion energy. So some other examples of kinetic energy, I'm sure you could think of some on your own. The moving airplane, when it goes up and down, that's kinetic energy. We also got water when it's, when the streams are going down, that is kinetic energy. So thermal energy, we're going to move on to a little bit different subtopic. So thermal energy is a kind of kinetic energy. So it's moving. Its thermal energy is moving. So as we know, all matter is made up of atoms, and atoms are always, always, always moving. Even if I look at this cup, it's made of matter. We can't see it, but all the atoms are moving inside. So technically, like these little atoms over here in this box, they're moving. The thermal energy is, the science definition is the total kinetic energy of all the particles in the substance. So how fast are they moving and things like that. Let's look at a more real life example. So I have these two cups up here. You can't really feel the heat, but this is cold water, okay? So this is cold water. Here, I actually heated up some water. I know you can't feel it, but you can kind of see the vapor, right? This is hot water. Which one do you think will have more thermal energy? If you said hot water, you're correct. Why? There are two rules you need to remember about thermal energy. The hotter the temperature, so the hotter the water, the more thermal energy it has. And more mass, so the more space it takes up, the more thermal energy it has. So let's look at these two pictures here. Hotter temperature, we got delicious iced tea, cold iced tea versus a nice warm cup of tea. The hotter temperature has more thermal energy because if you see here, all the particles are moving a lot faster and they're closer to each other. And the iced tea, the close-up of the iced tea, the atoms are just kind of chilling around, okay? And more mass. This beaker has a lot more water than this cup. So as you can see, the particles, there's more action. There's more motion. So more mass, hotter temperature, more thermal energy. Got it? Okay, now let's read the textbook. Technically, you can stop the video here and read the textbook pages on your own. If you prefer that, that's no problem. We're reading pages 86 and 87. But if you want to read with me, then keep playing this video. All right? Let's get started. Energy. Think about some of the things that you do each day. Maybe you have a refrigerator in your kitchen. You may have turned on the light. Hopefully you ate a good breakfast. Perhaps a car or bus took you to school. Someone adjusted the temperature in your classroom or in your room to make you comfortable. While these are very different activities, they all involve energy. Energy is the ability to do work. Some forms of energy are light, sound, and electricity. Machines such as cars use a type of energy known as mechanical energy. Thermal energy causes your room to be the temperature it is, hot or cold. Even the food that you eat contains a form of energy. The food provides chemical energy for your body's needs. You can see that energy comes in many forms, but energy would not be very useful if it could not change from one form to another. A flashlight works because of converted energy, so that's like changed energy. The chemical energy in the batteries changes to electrical energy. This energy then causes the filament of the bulb to glow, releasing light energy. Scientists sometimes classify energy as potential energy or kinetic energy. So that's the roller coaster example. Potential energy or stored energy is the energy that an object or substance has because of its position or condition. A roller coaster at the top of the track has potential energy. As the roller coaster starts down the track, some of its potential energy changes into kinetic energy. And that is the energy that an object or a substance has because of the motion. So flying jet and flowing water both have kinetic energy. They are both moving. Okay, I want to show you, just pause here for a second. I want to show you another example of potential and kinetic energy. So I have a notebook here. It's a cute notebook. It has a corgi on it. So I'm about to drop this notebook. Right now, what kind of energy does it have? Potential or kinetic? Potential, because it's in a still position. It's not moving. Once I drop it, that's kinetic energy. I'm sorry if that was loud. Okay. God is the creator of all matter and energy. But people use matter and energy as tools to meet their needs. Sometimes they change energy from one form to another. At other times, they use matter to produce energy. All right, thermal energy. All matter is made up of tiny particles called atoms and molecules. They are always in motion. This means they have kinetic energy. One kind of kinetic energy is thermal energy, and that is the total kinetic energy of the particles in a substance. The thermal energy of a substance depends on the temperature and mass of that substance. So the hotter it is, and the more mass it has, the more thermal energy it has. As the temperature of a substance increases, the particles move faster, and the faster the particles move, the more thermal energy it has. For example, the particles in a cup of hot water move faster than the particles in a cup of cold water do. Therefore, hot water has more thermal energy than the same amount of cold water does. The mass of a substance also affects the thermal energy of that substance. If two substances are at the same temperature, the substance with the greater mass will have more thermal energy. So for example, if these guys are the same temperature, this one will have more thermal energy because there's more water. More mass means that more particles are present and moving. And the more particles that are moving, the more thermal energy a substance has. For example, a large pitcher of water at room temperature has more thermal energy than a small glass of water at room temperature does. I think I said the word energy 300 times in this video. I hope this helped, and tomorrow we'll read a little bit more about temperature. We'll dive a little bit deeper into that and answer some questions in our workbook. All right, great job, and I'll see you in reading class.